Namaskar and welcome back to Integrated Manushya. So, how are all of you? I hope all of you are doing great. So, as you have read the title of this video down, uh, I'm going to discuss about energy. Let's do that. So, the first question is, what is energy? Well, if you have participated in a marathon, ran for a marathon, and have trained with a coach, and have got tired sometime while training, may have heard this from the coach. That's it? That's all the energy you have? That's why you can't run more? This is very bad. You have so less energy that you can't run more. Bad. Well, he may not say this, and I may have over exaggerated. But was the coach right on his words that you don't have energy, so you can't run more? I repeat, you don't have energy, so you can't run more. Does that mean if you have more energy, you can run more? Yes, he was absolutely right on that. When you have more energy, you can run more or any activity like dancing, singing, jumping, expressing. I'm expressing my thoughts to you as a video. Anything that requires energy. So I looked this on Google, and Google says that energy is the capacity of doing work. What type of work? Any work, singing, dancing, jumping, anything. Coming to the second part, how do we gain energy? Isn't it obvious? By eating food? Well, yes, we eat food and that turns into energy. So, food is some object or mass and we eat it, it turns into energy. Wait, what? We eat something, some mass, and it turns into energy. That's amazing, right? Well, is it true? But it is. According to Einstein's mass energy equation, not heard of it? You may have heard of this E equal to mc square, right? So, according to Einstein's mass energy equation, every object has energy. Mass has energy. Suppose this eraser, right? This eraser has some mass. So, the energy of this eraser or the energy that you get by completely destroying this eraser or the energy that is required to make up this eraser is equal to the mass of this eraser times the speed of light times the speed of light. So E equal to m, mass of the eraser, into c square, that is the speed of light whole square. What is the speed of light? It is approximately 3 into 10 power 8 or 3 followed by 8 zeros approximately. So that is the speed of light, and that's tremendously lots of energy. Coming to the third part, what all has energy? All matter has energy. This jacket, um, my phone, well, you heard the sound recently, sound energy, and even this light, the light I used to, uh, no, not the light, the plastic, the light I used to illuminate the room or the video. So even the plastic has energy, everything has energy. Wait, what? In the last video, I said everything is made up of matter, and now I'm telling everything has energy. So, what am I saying? Well, you heard me right. Everything has matter, and everything is made of atoms, and everything has energy. Even atoms are made up of energy. Seriously, they are. So, like I am expressing my energy in this video, expressing you, how does the atom express its energy? Well, it rotates, it vibrates, it has a to and fro motion. That's how it represents its energy. Let's do one thing for a better understanding. Let's leave this topic aside and go to another topic. I'll relate it back some other time or at the end. Let's take, for example, a hot plate. Suppose there's this plate, it is very hot. See, it's red also. It's very hot. It's not red, but it is actually red. It is very hot, and you're touching it. Immediately, your hand recoils, right? Uh, Now, what exactly makes this plate hot? What is it? Well, it is made up of atoms, but those atoms have energy, and the atoms vibrate. They go so fast, extremely very fast. So when you supply them energy slowly, and I mean when the temperature rises up, the energy goes up, the atoms start to vibrate with higher speed, higher speed, higher speed. And slowly as the speed gets higher and it gains temperature, it feels hot. That's why when you touch a hot plate, it feels hot. There's a lot of energy in those atoms. You may have seen the ice to water vapor transition. Ice has little energy. It is very cold. The atoms are very close together. Slowly, as it turns into water, the atoms get far away. They move about here and there. And as it slowly gets hotter and hotter, it moves extremely very fast. And till the time it turns into gas. And then after turning into gas, there's so much of space, it vibrates very fast. I mean, it moves here and there. Energy. The more the temperature, the more the energy. Right? So when I say that an object is hot, it actually isn't hot. It just means the atoms are vibrating too fast, extremely very fast. And when you touch it, there are millions and billions of such atoms hitting you at the speed of a bullet. So when millions of atoms hit you at the speed of a bullet, you feel heat. Well, taking so much of energy is not good. And if you are a kid watching this video and there's a storm outside your house and you want to go out there to get struck by lightning and to become Thor, then don't try it. Try touching a hot plate. It will give you a better experience of what is heat energy or what is it to take so much of energy. Well, actually, the Thor reference was not required. I just gave it to give a reference to the Avengers. But yeah, anyways, his new movie is coming up, right? Thor 4 Love and Thunder. Yeah, do watch it. So anyways, when an atom has so much of energy and you touch it, you feel millions of bullet kind of atoms hitting you and you feel something is hot. So that is it for this video. For the next video, I want you to find out that why does electricity flow? I mean, why do some materials conduct electricity and some materials don't conduct electricity, right? It has something to do with the energy of an atom. Atoms have electrons. When the electrons gain too much of energy, they jump up. I told you this, right? So when they jump up, I think I'm giving you too much of hint. I want you to find that out. And I hope you did the previous task on finding about phosphorus and boron. Was it boron? Yes, it was boron. So in this video, find out why do some materials conduct electricity and some materials don't. Thank you, and I hope to see you soon.